So, hello everybody. My name is Vladimir Kazanov, and I'm a lead data engineer at Badoo. Badoo is a dating social network, but actually Badoo Group has lots of brands, so all those events come from various niche dating social networks. Now, just some of the brands, Badoo being the biggest one. It's just a traditional dating social network. Bumble is more for like women. Chappy is gay dating. Lumen is for elder people. So all of those people constitute like 420 million registered users, which generate about 20 billion business events per day. We have much more technical events. That's about 2 terabytes of event data per day, 2.5 petabytes of data in Hadoop, and 400 terabytes of data in Exasol. That's like 100 machine in the Hadoop cluster and about 30 machine in the Exasol cluster. So I'm a bit of a technical person, and my team is doing mostly more software develop-ish things. So I'm gonna talk about systems we use and systems we develop to handle that load. So my department, called Business Intelligence Department, what do we do? So for us, the meaning of life is basically collecting user behavior information, because that's the most important thing we have in social networks. Now, the next thing we do, store the information. We pick databases, we build custom indexes, we pipe the data into those things. Now, by far the most important thing we do is provide insights to all of that. And based on that, product managers in the company can make informed, reasonable decisions based on real stats. So I'll do like a quick definition of what is user behavior for us. So in Badoo, user behavior is events, which is very simple. An event is just a timestamp, just a number, and a bunch of properties attached to it. So also events actually share some metadata, which is like generic, and it's available on every event there is. Now, I'll go through all the parts of defining an event and pieces of the pipeline that actually deliver the events and store them. So we'll begin with the UI for defining the events. Now, you can see from here there's the type of the event, which also contains a definition of all the properties available. Now, those properties can have types. The types can be the basic ones, like integer, a long value, or a custom type, like an enum, or something else. So basically, what you can say that every event type has a schema. So the life cycle of the event definition is the following. At first, analysts come to us or to the interface, and they do the declarative definition in the UI. From that, a configuration file is generated, which is just a YAML file. From that, periodically, we generate Prada files. If you ever heard about Protobuf, it's a realization library. Those are the Prada files used in that library. We use it mostly because for every platform there is a parser for that format. So we can generate anything we want using those parsers, and this is actually what we do. On all the clients we have, like mobile clients, web mobile clients, and others, we have those. So we auto-generate a client library based on that, and developers take those client libraries and actually implement logic sending those events. Now, having sent those events, we have to manage them somehow. We have to take all those hundreds of machines of the app service and then deliver the events to the Business Intelligence Department clusters. So we have 4 aspects to the system, like receiving the events, delivering the events, storing the events in the databases, processing the events, which means managing the pipeline, so we have to use a workflow manager somehow. We have to pick one. Also, there's a framework that will help us to transform data, because in various databases, in various indexes, in various systems, we use various data formats, so we need that. Now, the most important thing here is reporting, of course. I'll talk about that too. So the first stage is receiving the events. Having all those sources of events on various platforms, various brands, we need a tool that would allow us to gather those things and manage those streams of data. So in the beginning, we have those client libraries sending events. They end up on the app servers. That's like 100 machines. So some of those events are debug events. Others are like production events. So we have to filter those things based on some criteria. We have to route those streams of data to various places, and it can be complicated. Actually, in fact, we use a Facebook system called Scribed. They dropped it, and they probably dropped it for the very same reason. We dropped the system too and replaced it with a custom system that was built by another team in my company called Live Streaming Daemon. This is a very flexible and very useful tool. We never had any problems with that. So we route all the events to various targets, and it's really helpful for that. Actually, it's all open source, so if you're interested, you can find it on GitHub. Now, the next thing we do, and this is a bit controversial, but this is very useful for us, we batch the data. So every batch, approximately an hourly batch, gets an ID, which we call a job ID, and that batch gets loaded into the primary storage we have. So batching data has some downsides because it takes time. It limits us in some ways, and we cannot make immediate delivery. But on the other hand, if we have any problems with the data, we can reload it. And reloading a batch is easier because basically, if you want to check if the batch is right, if it's complete, the simplest thing you can do is check the number of events in that batch in all the systems and compare them. So if you do streaming, you have complicated things. If you have, like, say, a day of data missing, how do you reload that? Because, for example, in one database, there's one time format. It understands microseconds. The other database works in seconds. And because we have some custom systems, some of them really do work with seconds. So we use batches for most things. Now, when we deliver those events to the clusters we have to store it somehow. We have to pick databases and transform the data when we move it between databases. So the main storage, the primary storage we have that contains both the historical and recent data is HDFS. I really love it. I mean, I was at some point a bit skeptical about it because there are lots of distributed file systems, but right now I understand Hadoop and HDFS as more like an operational system that works in your cluster because you have resource management, you have various applications working in the database, in this file system. This is very useful. So now, when we load data into HDFS, the main format we use is org. Now, org is very useful because it's a columnar format, and it's more or less standard. So there are lots of applications and Hadoop that can work with it. And, well, some of them are more efficient, some are like less efficient, but they all understand the same format. Now, it's also, the format itself is also very efficient. It gives some nice, it has some nice compression properties. So yes, right now we intend to stick with it. So the main architecture, so to work with those org files, we use Hive. Now, Hive, I can say it's a database application on top of Hadoop, which can have access those org files, which is amazing. It gives you SQL-like language with certain limitations, and it's definitely not ANSI SQL, but still quite good. Now, this means that for all the historical data we have, for all 2.5 petabytes of data and like 80 machines or 90 machines, we have access to all of that, and we can actually write queries if we need that. But most of the time, we need something else. We need like recent data. And also because the data in Hive, in that table, did not go through any validation, it's actually basically every row in that table is a map of strings to strings. So the data, even though it's defined as having a schema, it doesn't have a schema in that table. So all the excess we make, all the nice work properties are gone. So it's like a data lake. There are several reasons for them. The main one being we just want to load it as soon as possible, not do any processing. We delay it till later. So the next thing we want, and actually analysts really like it, is having a data with a schema. So for that, we use Exasol. Exasol is both a columnar database and a distributed one. So columnar databases have several aspects which are really useful for OLAP queries, which means they're really efficient for analytical queries, which are the whole point. So Exasol is good with that. Now, distribution gives you space, storage space, which is also very important. So this is what allows us to have like 400 terabytes of data in the cluster and do really efficient queries to it. I'm talking about minutes when like comparable systems don't usually make it that fast. Hive, for example, for the very same 3 months would take, I think my recent query took like a couple of hours at least. So Exasol is amazing. Now, the schema is a bit different here. So for every event, we have a table. And all the properties already have types, proper values, everything by the time they make it to Exasol. And because Exasol really supports ANSI SQL, at least most of it, because nobody supports all of it, as much as I understand, what analysts love is that they can just join various event tables and do queries against those things. This is great, because you don't have to teach anybody any new languages, unlike some other systems we use, like Yandex ClickHouse or even Hive or Presto or other HDFS-based systems. So it's very convenient for us. Now, the next aspect we have is data processing. So we have those data storages. We have various custom indexes. I'll talk about those in a second. And we have to transform data between them. So the system we use most of the time is called Spark. You probably heard about it. So it's a Java framework that allows to execute complicated graph-like queries over a cluster. It also has one thing I especially love. It has an SQL language, which is you can use alongside the usual queries with all the power of Java. So it has a code-based optimizer. It knows about the cluster. It can decide things. It can help with like data locality. So when you execute a query, want to do some transformations in Spark, I try to do as much as possible in a SparkQL. And when I can't do something, I use raw Java, which is very good. The previous system I used is not that flexible here. So we use Spark to cook data for Exasol, and Exasol accesses actually the data directly in HDFS, which is also nice. So the other system we use is called CubeDB. I'll show a screenshot of it. So we also use Spark to generate data for it. And finally, we also have various custom indexes. So even though Exasol is fast and Hive has access to all the data sometimes, just sometimes, we want to do like live exploration of data. So this is like 80% of the things we do in my team. We build those special event indexes. So the other aspect of processing is workflow managers. The main system we use is called ZQ. It's some custom code. It's very similar to what Apache Airflow does. It allows you to run various scripts. It allows you to schedule things. and then you can define a graph of things with dependencies, retries. It has a few different architectural decisions behind it. For example, it uses a declarative configuration file, which I always prefer to code because that helps, very predictable. Now, the other system we have for workload management is called ETL master. That's a system built around Exasol. It's very similar to DQ. It does the very same thing, but it has Exasol-specific touch to it. So the ETL team we have works a lot with Exasol to transform data, prepare it for loading to other systems. They use this system. It's more like a historical thing for us. Both systems are, I don't think they're open source now, but if anybody's interested or curious about the code, I think we can do something about it, but we need some interest here because, I don't know, most people will just take Apache Airflow and be done with it. So the last thing is the most important thing for us because this is the way we present data to customers, and customers are within the company, of course, is various reporting tools. The main one being MicroStrategy. It's a universe of its own. It has dashboards, reports, all kinds of reporting you might want to think about. We have a couple of people working on it, maybe even more. So it's good. So MicroStrategy in Badoo works against Exasol. So it uses the data generated or transformed within Exasol. I'd like to give you a few screenshots of the interface, but the lead behind the MicroStrategy team said no. It's a huge secret. So I'll show you another interface. This is a custom system we've built. So we have all those analytical systems, and we had this problem is that sometimes we want to make like certain queries, a very small subset of analytical queries, but real fast, like in seconds. Mostly because we wanted to present those things in this interface. So it's like a technical interface used mostly by testers and programmers and us. It allows you to slice and dice and group data. So for example, this is a very important event you can see on top. That's the name of the event. And you can say like which versions have more of them, group it by various parameters, and all of that happens on all the data we have for multiple days in seconds. Depends on the size of the particular cube. Unfortunately, we're probably going to replace the system by something else soon, but, well, we'll see how it goes. So if standard systems, standard reporting tools like MicroStrategy and CubeDB do not work, people go to analysts, which write queries against Exasol, which usually work in like minutes or tens of minutes. So if that doesn't work, they go to Hive, which works in like half an hour, multiple hours, many hours, even days for some bad written queries. So if even that's not enough, or people have like very special requirements, we have some custom systems which were built by my team. One of them does funnel analysis. So you can define a graph of events here and certain parameters to it, like mention the events you want to see, and it goes through all the user sessions, like chains of events, and starts counting how many users reached a step in that funnel. And all of that works like in 3 or 4 seconds, so that requires a very special index we have. So yeah, that's a very interesting thing we do. That's my personal favorite. So the next thing we have, it's called session search. Sometimes people want to take a look at what do people do, given certain parameters, like a set of events they want to see in this session, or a set of, yeah. So they can go to the system and do some live exploration, because it works in seconds. Once they're done with it, they can just go to Exasol and do further exploration, because Exasol has some more data, much more data. It has some data from additional sources, not only events. The other system is very easy to understand. It looks into the stream of events that's incoming from the live streaming daemon, and allows you to filter the incoming events based on basic parameters also. So, for example, if you know somebody by a user ID,
they are usually anonymized, so you don't know a certain person, but testers usually do know their user ID. So they go and see how the app behaves event-wise into the system. You can actually look into the live stream of real people, and that's like millions and millions of people, and filter it, and it just works just fine. The only problem is that the interface gets explodes at some point really soon. So those are just like major tools we have. There are other systems developed by other teams. I'll just list them. So we have this unified BI portal, which is a single window into everything we do, all the reports, all the notebooks, all the definition languages. It has a very good search. That's the most popular feature of it. The other thing we have is called anomaly detection. So for example, you have a data source, any source you want, which provides data in a timely fashion, and you can run the system against it, and it will tell if there are any anomalies. And eventually, of course, it needs some data, aggregated data first. So, and when something's wrong, it starts shouting real loud. So we make experiments, and we have a couple of production systems based on Yandex ClickHouse, which is like, I'd say this is a lower level tool for us, because it means that you have to understand the problem you're solving first to use it. It's a tool that allows you to build distributed tables, like a table that takes like 100 machines. And there are various engines for those tables, depending on your needs. There are various things you can do. But the biggest thing you cannot do, which kills half of the fun for us, you can't do any joins, because all you have is a single table containing all the data. You cannot physically do any joins by definition. Now we have lots of data science things and data science work going on, but I don't know much about it apart from like keywords, so I won't go into it. So two other popular systems that were requested by our analysts, and they make a lot of use of it, especially for reporting, our notebook systems. So those are Zeppelin and Jupyter Notebooks. It's like when you want to write a report and some inline code, which can be run at any time, you use one of those things. Very useful for analysts, not very useful for me, but we do have them. So that's it from my side. Thanks.